Tonight's presentation is somewhat different from our usual arrangements where we've been talking this year about AI and other fairly high-tech things, but it's a very important part of the engineering profession, the provision of power on a temporary basis, temporary being only perhaps a matter of a few days. We're particularly fortunate tonight to have one of the UK's leading experts in the field, James Eade, who's going to come and tell you exactly how these things are planned, installed, managed, and so on.
Thank you very much. I'm delighted to have been asked. I feel quite honoured to be asked to come and talk with such illustrious company. And so a very good evening to everyone and everyone online as well. As Colin's intimated, my background is very much an event. I started lighting plays at school, but the career paths back then were fairly limited. And so I went to university, did engineering, spent more time at the local theatre than I perhaps should have done, but did manage to get a degree on the output. And from there, apart from a bit of time in the Royal Electrical Mechanical Engineers, TA, basically spent a career doing shows. And I've worked now in most genres, from theatre, film, TV, large-scale public events. And so over the years, we've built up quite a broad picture of temporary power. And what we've developed in events now are very much widely used, actually, or becoming increasingly used in construction and other sectors as well. Some of the techniques, the tools, and the technology that we use. But having come from AI and other conversations, I'm going to bring you resolutely back down to analog and 50 hertz. So something quite straightforward for this evening. So in terms of the events industry as a whole, a lot of people have all been to gigs. And given that we are now getting to panto season, I thought we'd do a bit of audience participation. So my question to you is, hands up if you've been to a live music concert in the last year. Hands up who's been to the theatre. Oh, that's good, good. I was expecting a sea full of engineers to go, you what? but no, it's good to hear. Now, everyone's been to concerts, everyone's been to the theatre, everyone's been to see football matches and shows and watch television and things, but not many people actually really understand what goes on backstage and what an industry it is. And during COVID, the industry was really decimated and the government handouts were limited because all they knew about was the Arts Council, which only caters for a very small section of the industry. And so the industry went off and did some research to try and present to the government what the scale of the industry actually is. And the output, as you can see in the infographic on the right, gives you some idea. So live music alone contributes about 30 billion. The workforce, 72% freelance people. We lost a lot of people after COVID because loading trucks at 2 o'clock in the morning wasn't quite as it wasn't quite the lifestyle that people wanted, really. So having learned that they could load trucks for Tesco's at the same money, they left the business. So we've got a big skill shortage now as well. But in terms of the actual technology, the development, the construction of equipment, that's over 1 billion. And collectively, the events, leisure, and performing arts, TV and film contributes around 100 billion to the UK economy every year. Now, to put that into some perspective, the food, farming and agricultural sector, according to the NFU, is 110 billion. It's about just under a third of the size of construction. And what did surprise me is, if Google is to be believed, that it's about twice the size of the aerospace sector in the UK as well. So in terms of an industry, although most people haven't really heard about it or know much about it, it's big. And it runs, like many industries, on power as well. And I'll come on to that. Does anyone here work in STEM as a STEM ambassador or deliver talks to school? If you do online, I really recommend it anyway, and if we do have time, we could see it, is that YouTube link. If you follow that was recently done by a company called Ad-Lib Audio, trying to encourage people into the sector. And it takes you on a tour from right when a musician says, I'm going to record a new album, all the way to that tour traveling around the world. And, big events, we've all heard about Taylor Swift. These things go in fleets of Arctics and tour between venue to venue, country to country, continent to continent. And it's a massive operation when you see how these things operate. When I was working in stadium-sized tours, we had, you'd turn up at the venue, unload all the trucks, rig all the kit, and you'd be up and running ready for the show in about 36 hours. And the whole thing disappears in even less time. And there's usually about 3 sets of staging that sort of leapfrog around the world as the show moves on. And that's just live music, and then you've got the film and TV and all the rest of it on the back of it as well. And so like I say, definitely well worth a look if you get time to watch. Now, as we know, power is used by us all, and without it, we're a bit stymied. But in an event context, we've got security, we've got the all-important catering as well, lighting, rigging, video, and audio. And video now is a big part of the visual image of most shows. And I'm delighted to know that we've got a sound engineer in the audience as well as another power person. So I might lean on you for some comments later. Now, when I was asked to give the talk, when Leon collared me at a meeting, one of the IT standards meetings, I just envisaged sort of chatting to a few people in the room. Didn't quite sort of gather the scale of the network's delivery. But when I was asked to talk about backstage power, that's the sort of thing that sort of came to my mind, really. So, we use a lot of high-powered loads, so we often have a lot of generation, or use installed supplies as well. And all of this stuff is designed to be connected together, plugged up, unplugged, taken down and put back on the truck and taken to the next venue. On the right-hand side, I won't move too far, otherwise I'll get out of view of the camera. But you can see the distribution, the front side of what you can see in the top photo, basically. And where you can see the Averlight dimmer racks, each of those flight-cased racks is 48 channels of 3.5 kilowatt dimming. And so, again, a lot of power just in the small little box. On the right-hand side, you've got 96-way mains distribution units, so basically giant consumer units, but all flight-cased that you can just plug in with a 400 amp supply at the bottom. And on the back, you've got the multi-core connectors. And those are really commonly used for lighting and mains distribution for video, and lighting predominantly as well. So there's a lot of hardware that goes together in a very short period of time. Now, in terms of the planning, there's some key themes, really. There's a source of energy. Where are we going to get our power from? Is it an installation? Are we going to use generators? Are we going to use sustainable options, whether it be solar or hybrid battery-based setups, which are becoming more common now as well? And the emergency planning and resilience usually is the backbone to any power plan, because there's 2 elements to it, really. One is the safety aspect, and the other is the commercial considerations. So when you're looking at a big festival site and you've got tens, if not hundreds of thousands of people, if someone plugs in a dodgy kettle backstage and the main earth leakage relay goes on the generating plant and you plunge everyone into darkness, you've got a massive crowd control issue. And you can't put messages on the video to tell people not to panic, to go or stay put, or whatever it might be. And you can't use the PA because the PA stopped working as well. And so having that resilience in the system to be able to enable that communication to happen with your massed audiences is very, very important. There's also the commercial side. When you look at some of the telephone number type figures involved in rights for broadcasting and similar, if the power goes off and the OB truck shut down or the camera outputs are lost, then again, big financial penalties are at stake. And so there's a lot of interest, depending on the type of production, from a financial aspect in that as well. And I'm going to come on to the Commonwealth Games in a minute, but in terms of the resilience, in the Games venues, every venue had an A and a B supply, one of which was backed up, even though we were using a grid power option first. And in places like the NEC, which hosted quite a lot, we used supplies from 2 substations and backed one of those up as well to provide resilience for the actual main broadcasting hub. Even things like the fridges for the specimens from the from the sports people had to have a resilient supply as well, because you didn't want the specimens to go off. So there's a lot of planning that goes into that sort of dual redundancy aspect. And most of the networks are all dual redundant with A and B supplies as well. So the final thing you need to kind of look at is, what are you plugging into it, and work out with loads. And that conversation goes a bit like this. You start off by sending an email. Dear John, I'm doing some planning for the reality gig. What are your power requirements? Hi James, good to hear from you. We need 2 400 amp 3-phase supplies backstage left and 125 amp 3-phase front of house. Cheers, John. Thanks John for the quick reply. Understood on what connectors you need. What is your actual load? No idea. Can I give you a kit list? And so when we look at the planning for these things, you often find people saying, yeah, I need a 63 amp 3-phase supply. And you then have to educate them and say, no, you don't need that supply. That's the connector you need to power up your kit. What you need is, a couple of kilowatts or something like that. And even now, with a lot of events, we don't know what the actual loads are going to be. So there's always an element of oversizing. And so from a generation point of view, we try and mitigate that by using load on demand and other methods. If you can send a spreadsheet out and get people to populate it with what they're plugging in, that's great, but most people don't have the time or wherewithal to do that. So there's often a lot of second guessing using empirical data that you've gathered before on other jobs as well. And of course, you also have to plan for the unexpected, because it doesn't always go just the way you wanted it. So people doing silly things with earth electrodes, stuff getting waterlogged, kit overheating and burning out. And you've got to make sure that you've got you carry the spares with you, you've got the auxiliary supplies and equipment you need to be able to bypass things like that. Because believe me, if you've got an audience waiting in front of a stage for their favourite musician to come on, and you've got a power problem, then the pressure really is on. And it's very, very rare that a show actually gets cancelled for technical reasons. And when you hear that, it's usually actually a fudge, because the actors or whatever have had a little wobbly. But technical issues are very, very actually rare. In terms of planning, I'm going to give you a quick sort of whistle-stop tour through the Birmingham 2022 Commonwealth Games. And a lot of this will be replicated in Glasgow, but on a smaller scale, partly because I haven't got much time to do anything between now and the start of those games. It was the largest event we've seen in the UK for quite some time, actually, probably since 2012. And at the time, we pioneered quite a lot of new techniques. And I'll come on to those in a mo. But yes, large geographical area of the West Midlands. The only one standing out was Lee Valley Velodrome, because they didn't want to build a new velodrome in Birmingham, so they used the one in London instead. So that was the only one off the patch. There was greenfield sites like Cannock Chase for the mountain biking, sort of semi-greenfield like Victoria Park. Although it has a clubhouse, it's not exactly a suitable venue. And then, some of the main ones are in places like the NEC, which are really geared up for that type of application. And in total, when you include the non-competition venues, there was about 29 venues in total, as I remember. So that includes things like the accreditation centre and other venues that all need to gain power and systems being put in. So in terms of the topologies, we did a mix of, the basic design was to use grid power, because in the UK, the national grid is not all that bad, actually, and it's particularly in larger venues, it's quite robust. So we did an exercise of reviewing the distribution arrangements from Western Power to each venue, and paid for things like automatic restoration switching to be put into some substations, so that we didn't have to pay for a Western Power distribution guy to be on standby in the substation in case they needed to switch over between different parts of the grid. And having done that, we then looked at the backup arrangements and basically ensured we had that redundancy in place. So on the right-hand side, you've got a picture of the centre of Birmingham where the beach volleyball and other bits was. So that was one of the generator compounds there. with 4 generators going into a main panel. And we did quite a lot of battery storage as well. And with this, there was a big education piece, because when you turn around to broadcasters and other big stakeholders and say, how you've always done it, we're going to do it a different way, it's a big PR exercise. And the technology will only get adopted if people actually do it and show that it can be done. And following this, a lot of confidence grew in using batteries particularly. And a company called Power Logistics, when they did the coronation recently, did I think what was the largest deployment of batteries so far on a major event, and they put 26. So everything from the camera locations at the Queen Victoria Memorial at the Mall, all the way down to the Trafalgar Square, had quite a lot of battery storage, as did the OB compound in St James, Canada Gate as well. So it's growing in confidence, and people are deploying it more now. But even now, big batteries of the sort of multiple 100 kVA type scale are few and far between. Plenty of smaller hybrid ones, but when we're looking at the sort of power planning for these things, we're in the hundreds of kVA market, not the tens really. So the most common and typical way we've powered events for years is to have a dual redundant generator model. So you have two generators running in parallel, powering the load, so that if one of the generators falls over, the other takes the load seamlessly and everything carries on, which is great. But the challenge with that is they don't run efficiently, because if you split the load between 2 generators with the aim of one taking the full load, they both by default are going to operate at well under 50%. And as we'll see in a minute, this is a real challenge when it comes to the new Stage 5 engines. Does anyone have a diesel car that they put AdBlue in? No? Yeah? Well, you're all electric cars. Very good. But those, you'd probably be familiar with AdBlue on sale. And so the new Stage 5 engines run on that sort of same principle. But the biggest challenges really are not at the sort of time of the show. It's in the evenings when you've got the security team sitting in their office watching television, making the odd cup of tea. And you've got these big generators chuntering away outside just to keep a few networks and their kettle alive. So you end up running the systems very inefficiently, and we specified in the original planning Stage 3A generators for that reason. So, but the challenges with the Stage 5 units is that the Stage 3 units is they got greater emissions. And the Birmingham Games was the first carbon neutral games. So although we wanted Stage 3 units because we know how they work, you can't buy them anymore. And a lot of companies now have all got Stage 5 engines. And the Stage 5 Euro emissions compliant engines actually need to run hot in order to work the catalyst and the exhaust. I'm not quite sure how exactly they work. But they've got to be under significant load, so more than 60%. So automatically, that rules out your plain twin set generator model. Because if you don't load them up properly, then they run inefficiently and they shut down. And so, like I say, we can't have generators turning themselves off because they don't like their exhausts getting clogged up, which is the whole reason for the Stage 3 requirement in the first place. So that automatically led to the concept of really deploying batteries. And as I said, it was much more of an exercise in PR in terms of getting people on board and making sure that they're happy with the technology. And we did have some teething troubles, as we'll show you in a sec. But the basic principle is, for the most part, you run the loads on the battery, and then you just use the generators to charge up the battery. And when you're actually on air or live at the time, then you can just run the generators as a parallel backup as well, just in case the batteries fail. And we had a lot of success with that. So here's an example of the ceremonies compound at Alexander Stadium. So this is where the outside broadcast compound was, but it was also the production area for the ceremony, opening and closing ceremonies. And that was up and running for quite some time ahead of the actual main fit out for the games. But you can see on the graphs the input power and the output power, and you can see during the day when you get the big spike when everyone's at work and setting stuff up, and then at night it drops right down again. And the actual running time of the generators, rather than having them on for 24 hours, a generator, rather than two, ran for about 5 hours a day just to charge up the batteries. And so we saved a lot of diesel, which when my diesel budget started off at 600,000, the government abolished the rebate on red diesel during the process. I ended up spending 1.5 million on diesel. So, what I can save is quite good. But in a bit more detail, you can see the typical load profile for a day, where you've got the main sort of power output peaking sort of during the working day and then tailing off at night, and just the generators charging for that short window. And so it had a big impact on the effectiveness of the operation. And in terms of the stadium itself, where the ceremonies were in a lot of the athletics, we had 4 main compounds. We had the north and south generator compounds, which were duplicates of each other. The broadcast compound, which is the one we just saw the pictures for, and then the pedestrian screening area down the bottom. So that's where everyone comes to the stadium. They have their bags searched. They've got the X-ray machines and what have you. So and some of the concessions, so people can get a bite to eat, was down on the south side. And for the venue itself, we did quite a lot of looking at seeing if we could augment the grid power there, but there wasn't much available, and it was all concentrated down by the PSA compound. So even if we did want to use some of that, we'd have to do massive cable runs all the way around the back of the stadium, and it's really too impractical to do that, and too costly as well. So hence we had the distributed generation around the venue. The compounds were filled with this kit. So north and south, like I say, duplicates of each other. Had 3 600 units, 3 300 and a 300 kVA battery storage, which did the low load periods. Broadcast compound, 4 200 kVA sets and another battery unit. And then the PSA was a smaller affair with a few 125s. And all of those configured for parallel operation and auto starting, so that as the loads increase, you bring the generators on stream as required, rather than just running, a couple of sort of sync pairs of 500 or more generators. In terms of the configuration, the generators all plumb into basically a 20-foot shipping container. You can just see if this works. You can just see at the end that shipping container. It's basically a 4,000 amp low voltage busbar chamber. And so all of the generators plumb into that, and all the outgoing circuits come out the back of it. And the generators on the right-hand side of the bottom photo all cabled up into that unit. And you can just see one of the AdBlue buns there that are used to feed the things, the exhausts with the AdBlue to mix in to get the emissions down. But the advantage of doing this model is when it's very low load overnight and similar, the battery can power the loads, and then the other generators can be bought on stream as required as the action gets a bit busier. So we're mitigating the actual running time of the generators and the diesel burn at the same time. From a protection point of view, pretty much all circuits, although it's technically not a requirement in BS 7671, for the most part, all mains distribution circuits are protected by earth leakage relays or residual current monitors to provide that sort of additional protection, if you like, because as you can see, a lot of the cables are running on the floor, but generally those are only in controlled areas. But the cabling, the connectors we use are known by the brand name Powerlock, and they're 400 amp or 600 amp rated connectors. And so you have 5 wire sets for the 3-phase distribution around the venue. Now, in terms of the challenges, what we found was that the battery storage units don't care about power factor and things like that. The inverters are pretty agnostic about this, which is great in some respects. But then when you transfer the load onto the generators, you suddenly find that they don't like it. And this was the setup for the opening ceremony. And you can see where the cars are in the middle. Around the perimeter, there's an LED screen. And what we discovered was when they turn the screen on, the battery's dissipating a bit too quickly. Start the generator up, transfer the load onto the generator. The leading power factor made the generators instantly shut off again. So we thought, oh, that's not what we expected. But there's without boring you with the maths, there's a very basic graph of power factor operation on generators. Lagging power factors, where the generator engine has to work harder to turn the alternator, you can cope with quite readily, and that's that nice big green region. But what you can see, if you look at the black line, is you just got a very thin whisker of green on the left, which is the leading power factor. Now, most switch mode power supplies are slightly capacitive, and the effect of that capacitance creates a leading power factor, which causes the alternator to accelerate, basically, and the generators can't cope with that. And so there's a very, very thin window where they can run with leading power factors before they become unstable and turn off. So so that was our first challenge that we had to overcome. If the way around it, of course, is just to bring more generators on stream. But of course, if you bring more generators on stream, they don't run efficiently. So the engine exhausts clog up with crystallized urea, and you can see in that bucket a lump that was taken out of one of the exhausts with a little hole at the top, which is where most of the exhaust was managing to escape through. So it becomes a real challenge. And a way to cure that is with load banks. So you stick big resistive loads onto the system to keep the generators happy because of the leading power factor issues. Now, it just so happens that chatting to some colleagues, or I'll come on to that in a sec actually, the other bit is harmonics as well, because switch mode power supplies really are the curse of any power system generally. And you can see on the screen grab of a power quality analyzer on the top right, a certain big festival that we've all know and love. And this was the lighting rig for a particular artist. It had a lot of incandescent lamps being driven at about 50%. And so you can see the phases were not badly balanced at sort of 360 amps, but the neutral current was 550. And if you stick 550 amps down a 400 amp connector, you can guess what happens. And for those who deal in power, if you lose the neutral, it gets very expensive very quickly. So power quality is a really big issue now. And the bottom graph shows the harmonic spectrum of the neutral current. I can't remember what the fundamental frequency was on this, but you can see the real prevalence of third harmonics, so the third, ninth, the triplins, third, ninth, 15th. And those are the ones that really add up in the neutral itself. And when you add all of this together, the demands on the temporary system, really can be quite challenging. So although we're using less energy, the way we draw that energy from the supply is much more of an issue. And some of the odd order ones can cause overheating in alternators. And I remember doing electric vehicle charging on the EV championships, and when we looked at the harmonics and we phoned up the manufacturer of the alternators, they said the alternators need to be derated by 50%. So our 250k generators suddenly were only used for 125. So it becomes a real challenge in terms of generating efficiently and safely the power that you need without causing systems to fall over. So like I say, load banks are a common way of curing these issues. But at a same said festival, chatting to one of the power people there, they deliver a megawatt's worth of load bank to site to help keep the generators happy. And a megawatt, I worked out in a fag packet calculation, so forgive me if it's not quite right, but it would bring an Olympic swimming pool to boiling point in 17 minutes. So that's how much energy is being wasted to try and keep generators happy, because we're all going, oh, look, we're using LED lights. Wonderful, isn't it? And so that is one of the, again, like I say, quite a headache for temporary power. And also this is true of networks as well, the grid and so on. So yes, it's not uncommon, sadly, although we managed to avoid load banks for the most part using batteries, we still had to deploy a couple, predominantly at the stadium actually, to try and keep the system stable and working effectively. The other thing we did was solar, and solar's great, but as you can see, you need quite a lot of space. And of all of the venues, finding enough real estate within what's known as the red line boundary, basically the security perimeter, in a nice southerly facing position, is a challenge, to put it mildly. And this is the only venue we could. And even here, we had to apply for change to the planning permission to be able to change the red line boundary into the park. But when we told the local residents that we'd be able to turn the generators off overnight, they didn't object to the planning. So it did have a positive aspect. And with this setup, we had the solar providing a baseline level of power, a stationary backup generator feeding into a battery storage unit. And basically the solar did, a good level of baseline generation, and the generator could just be bought on stream as required when the battery starts getting a bit low. And like I say, requires a lot of space to deploy. And I worked out that our output was about just over 100 watts a square meter, which is not the most efficient method of generating electricity, really, but it does help the overall picture if you've got the space. So in this one, we had a design load of 780k, and you can see the schematic of how it all plumbed together with the solar panels and the inverters going onto the common bus. Now, in terms of challenges for this one, again, one of those things we hadn't really thought about. When we'd managed to network them all together and get them sort of on the bus, all synchronized, when the sun came out and the solar started generating, the generator saw that as reverse power and shut down. And so there was an element of trying to engineer the controls to get the inverter control, which is a completely different manufacturer, different protocol and everything to the one in the generator, to try and get the systems working together effectively. So, and the other thing we had is the battery unit failed and the generator didn't auto start. So there's a lot of fault modes with these sorts of things that need thinking about and planning previously, before actually going live with the show itself. And for the most part, touch wood, everything worked absolutely fine for the shows and the events and what have you. But as with any new technology, and a disruptive one at that, actually, in this application, it was a bit of a challenge. We also had took a different model, which is very unusual in sporting events, of saying that broadcast can have the same supplies as everyone else. Broadcast, yes, we know is important, but so's the rest of the gig. So we ended up putting the broadcast, lumping them onto the same distribution, which for them was a first, actually. And again, a bit of a PR exercise. And that's something that's been taken up by the International Olympic Commission as well, in terms of, providing that confidence that that sort of thing can be done, because they came around and had a wonder. Net gain, though, was quite good, over 10 megawatt hours generated by the solar, and that represented about 33% of the actual overall venue consumption, with the remaining 67% being done by the generator, but at least the diesel burn was reduced by using that hybridized setup. So all told, good result, learned a lot along the way, and like I say, a lot of those lessons are being carried forward now. So I touched on earlier, the NEC was a host for quite a few venues. Now, in the NEC itself, I don't know if anyone's been there, but underneath each hall, there's a load of subways where there's the distribution buzz bars for the main power, and there's two sets of buzz bars fed from separate transformers, so you've got the resilience built in. And for the broadcast hub, which is in one of the halls with all the trucks parked in it, we took the power out from the buzz bars in through a UPS with a stationary backup generator, and then back onto the buzz bars again, so that the whole system was backed up, or at least one of the buzz bars was, particularly for the broadcast. And in there's a lot of trucks, all with their aircon running and things like that. So the load's quite considerable for the most part. So a lot of forethought and planning goes into that. But having said all of that, during some of our planning process, having looked at Carbon Intensity's website, this is what the national grid makeup was like in 2022 in the summer. So in the West Midlands, 65% or just under of the generation during the day is on gas. And given we're running the generators on HVO, hydrogenated or hydrotreated vegetable oil, I think actually we would have been greener running everything off generators from a carbon point of view. There is a big debate about the provenance of the HVO itself, but leaving that aside for a minute, I think in many respects we would have been better running on Jennies. And we did for the electric vehicle charging compound just by Aston University. We had right by the Aston Expressway. I don't know if anyone spends much time in Birmingham, but it's a big sort of 6-lane highway in and out of the centre of Birmingham. And right next to that is the electric vehicle compound with some big generators and big battery units charging the electric vehicles. And I had my press release written, ready to issue, when someone from the public sort of cottoned onto this EVs being charged off generators. That's not very green aspect, but luckily they didn't come. But like I say, in reality, it was probably a greener option given the general makeup of National Grid generation at the time. So yeah, it's an interesting website if you ever get the chance to go and have a visit. It's got a lot of information on grid supplies and the general makeup of our power distribution or generation. So yeah, so that was that one. In terms of numbers, we had 26 mega VA of generators, a lot of fuel, 29 UPS systems, 3 meg of battery, all told, 140 kilowatts of solar, 2,000 distribution boards, a bit like the one at the bottom, 500 kilometres of cable, and a big fat budget to do it all. And when you bear in mind that in terms of the actual power planning, that went on for a good year by the time we got a Greco, our contractor, on board. But the actual fit-up, the actual doing the work, started a few weeks before each venue went live. So that's when the trucks start rolling up to site and everyone starts plugging everything together. And again, power is usually one of the first to go in after the security shield's up, because everyone needs power. So we sort of tend to be early to the party and quite late to leave. The one exception with that was the stadium, because with the ceremonies, rehearsals, that was in use for quite some time prior to that. But then that was a lot of hardware down there. Now, I don't know how we're doing for time, but we've got a few minutes still. When I saw the title of the thing, Shining a Light on Backstage Power, I thought, gosh, shining a light on things. Yes. This is what shining a light meant when I started in the industry. It was incandescent lights, rank strand, you recognise those. And it was all light bulbs, all incandescent, none of this switch mode stuff, and lots of dimmers. Control was, in the day, it was very rudimentary, 0 to minus 10 volt analog control lines, and I remember spending many a miserable day trying to solder up the miniature connectors with the analog lines coming out the back of the desks when you had a flickering channel or something like that. The serial DMX control, as it was known, based on RS485, was in its infancy, DMX 512. And people were slowly adopting this newfangled technology. And did you have any involvement in the Galaxy desk? You did, yeah. So when I was working at the theatre at university, that's my first computerised control desk, that brown one, which is one of the first early memory desks the Strand made. And the backup was on sort of 12-inch floppy disk drive type of thing that you know, like an LP, you slot it in the side of the machine and back it up. Nowadays, shining a light on stuff is really rather different. And the moving lights now, 40 plus channels when you've got color wheels, you've got pan tilt, you've got different modes of operation, fine, coarse, panning, effects wheels, gobos, all sorts of things. You know, they're easily 40 channels plus on some of the more expensive ones. And they cost sort of, 15 to 20, even £25,000 per light. So next time you go and watch a concert on telly and you see all these lights, or even Strictly Come Dancing. Any Strictly fans? No. It is a room of engineers, definitely. Yeah, next time you look at Strictly and you see all the lights going up, just think the value in that lighting rig, but also the automation. A big concert now has got more axes of automation than a factory production line. There's a lot that goes into these things. And so, of course, the control desks have grown considerably as well. And it's all on Cat5, Cat6 cabling, or even fibre, and you build backbone networks now for lighting distribution, as you do with audio as well. And it's a very, very different beast to when I started. But it still all needs power. 50 hertz, analog, good old-fashioned power, so we're safe for a while, I think. And I think, sir, that brings us to 45-ish minutes and Q&A.
James, thank you very much indeed.
It's a pleasure.
I think the sheer scale of what's involved is probably an eye-opener to all of us. The amount of work that has to be undertaken, if you like, for the planning. As you saw some of the numbers that James was talking about, it is not a trivial exercise. So, James, thank you very much indeed for a very comprehensive look at literally what happens backstage. I'm sure there'll be one or two questions that people in the audience have. If you would like to raise your hand, I will get this microphone to you so that we can hear your question. There's the first one. Thank you.
Yeah, please do speak loudly, because I forgot my, I didn't charge up my NHS in-ear monitors. I left them at home.
Thank you. Absolutely fascinating talk. I've been told at live events, particularly festivals, lightning is a real headache for the temporary power systems. Is that a real issue for you, protecting against lightning strikes?
Sorry,
lightning.
Lightning strikes.
Lightning, yes.
Yeah, do you know, interestingly, we wrote some guidance with the Trade Association Plaza around this, because in countries like America, they have a lot of bad weather, so they're quite well geared up for this sort of thing, but we don't in the UK. Now, when you look at the lightning discharge maps that are used in the British standard for lightning protection of structures, the risk of a lightning strike, for the most part, for the 2 weeks you're in a field in wherever it is pretty low. But of course, when it does come over, what are you going to do? And, you know, so the guidance really is about crowd management. Can you send the crowd somewhere safe? You know, like if we were doing something out here, we could send them back in the buildings. If you're in the middle of a field, actually, the safest thing to do might be to keep them where they are, because uncontrolled movements of people in the mud trying to get back, where are they going to go? A tent, which has got a metal pole in the middle? You know, it's often the greater risk might be actually in moving large numbers of people. So keeping them where they are is probably a better thing. And again, if you look on YouTube, something called Puckle Pop Festival, you look at the video there, you'll see a big rainstorm, and they announce to the audience, can you please leave? The audience look out the doors at this thunderous rain, go, no, go back in again. And people start sort of hiding backstage and all sorts. Just quickly to finish that off, Colin, while you go to the next chat, in Finland, a storm came over and everyone was told to go down onto the subway in the town. 6 people died, not because of the weather, but because of the crush injuries and things like that. So, yeah, like I say, it's from an electrical point of view, just disconnect as much as you can. But some things will need to be maintained for resilience, like emergency evacuations. A lot of comms now is on WhatsApp, and so you need to keep the mobile phone networks going. So some bits will be kept going, but unplugging as much as you can is the key thing.
I was fascinated by all the technical problems you overcome. Are you able to tell us anything about the pricing structure? I mean, do you charge them by the amount of kit you have to bring on, then do you charge them so much per kilowatt hour consumed? How do you work out how to charge your customer?
It is done basically on equipment rental. So we will supply X number of generators, X numbers of cables, these types of distribution boards, and it's a rate card basically. And so when you're looking at the power requirements for an event, you'll do a schematic, rough plan of how it's all going to go together. Look at the kit you need and price it up on that basis. Things like diesel is usually an extra, so that would be just charged at cost, usually with a handling fee for refueling and what have you. So it's basically it's commodity pricing as to how much it costs.
So you don't care how much electricity they use?
Well, no, because if you're charging for the diesel, they can use as much as they like. You just pass that cost on to the production company. And so that's the usual model in that respect. There is a slight Achilles heel to this, because if you start charging people for the electricity consumption, as memory serves me, you start getting in the realms of ESQCR, the Electricity Safety, Quality and Continuity Regulations, because you're a supplier. and that brings a different world of pain. So actually just providing power and charging for the diesel is an easier way around it. But that model is being looked at because obviously in events what you want to try and do is reduce consumption. So if you charge people per kilowatt hour for the burger van, for the video wall and things like that, you can get people possibly to think a bit more about it. But at the end of the day, they're going to do what they've always done, still use the same amount of energy. So, and everyone will just pass the cost back onto the producer. So you might as well just charge a producer directly, really.
Thanks a lot.
So,
Hi. So this is my day job. I work for an events company. I'm BS7909 trained.
That makes 4 of you.
I did power testing for 7909 sign off for Royal Ascot this year. And PowerGen had a lot of battery systems around.
Yeah.
So that was quite interesting. That was my first time coming across them. My question actually is, when do you see surge protection becoming a thing in distro units?
No. No, I know. When it was introduced, when it became, Leon, you might need to help me out a bit here, but it was the 18th edition of BS7671, there's a much greater requirement for surge protection. And when you read the requirements, it said, where there's a risk to life, where there's a significant financial loss, where there's a large number of people, and words like that. So basically you look at it and you think, bloody hell, that's every gig we do falls into that category. But in terms of the application of surge protection devices, there's quite a lot that needs to be thought about in terms of selecting the right devices at different parts of the distribution. And you've got to coordinate the device types, the manufacturer types, because they work in different ways. The protective conductor connections are usually quite stringent. And when you've got a load of different boxes that you're lashing together, some of which you've sub-hired from someone else because yours is all out on another, it will never happen. So there's no point. And the only company I know that's done it was a Greco, and they have some fitted in their boards, but that was because it was a contractual requirement of the 2012 Olympics. Fact good, it did them, but it's so no, don't lose any sleep over that. And also the other thing is, from a surge protection point of view, all our cables lie on the floor. Atmospheric issues are rare, and if lightning hits your structure, surge protection is the least of your worries, really. So, so you go. Are there any questions from online, Nigel?
Yes, we do have some questions online. One question is about skills shortages. A slightly different tangent to what you were talking about there. The question says that it seems that everybody's got a degree in sound or lighting these days. Are you talking about electricians or other trades that are the shortage?
It's lovely to have these degrees, but everyone wants to be the one operating the desk. They want to be the one designing or operating the sound system. We need people to put it together. And power, yes. That was the only thing about that ad-lib YouTube video. I need to go back to them. They've covered every discipline except power. So, but yes, it's broad. There's everything from IT people. The manufacturers also are desperately short of people to actually design the lighting desks, design the audio desks, the speakers. There's the whole supply chain is in need of skills in that respect. Electricians, yeah, absolutely. Skilled electrical people who've done their BS7909 training. Again, very, very short supply. But everyone wants to get in that creative side, and that's where some of the challenges are, really. Sorry, I should be addressing that answer to the camera. Sorry, Nigel. So hopefully that answers that question. Any more from the floor?
Sorry, mine's not really a power question. It's more about lighting. When you put a light on, it shines on somebody and you see them by reflected light. But during the proms this year, I saw lights moving across
Tracking
each other in the background. And you could see the light, but there was something swirling. Is that dry ice swirling in the light beam so that you can see it?
No, what's used is it used to be something called cracked oil machine, but it's a haze now. So it's a very fine mist of atomized fluid, basically, that gives that mist effect. And so what you see is so it really accentuates the light beams, because otherwise you don't get that sort of full visual spectacle, because all you'll see is pools of lights on the floor. So to get the beam effects, if you like, then you need to have that sort of haze in the atmosphere. And that's created using a hazer, basically, and quite a few of them. And sometimes you see these being used in outdoor festivals. I don't know why they're bothering, because it's all just blowing off the side of the stage. But yeah, so that's what creates that lighting effect. Dry ice, yeah, it's died a death a long time ago. There's actually cooled fog equivalents. So similar sort of smoke machine generation, but they cool it down so that it lies on the ground and creates that dry ice effect. But yeah, dry ice, I haven't seen dry ice for donkeys.
Thank you.
Years.
Just thinking about that, the evolution of dry ice. One of the questions from Drew, he was involved in the Commonwealth Games, and
Drew Belcher.
I'm guessing, yes, Drew B. Yes, that sounds like.
Hello, Drew. How are you?
With the benefit of hindsight, what should we look to do differently in temporary power going forward, do you think?
That's a really good question, actually. Do you know, I don't know the answer off the top of my head. I think placing a greater reliance on grid, so particularly things like stadium tours, you can, rather than running generators, you can actually use battery storage, charge it off the grid during the day, and the batteries can do peak shaving. So they can take the high loads for the show, and then they can charge again overnight and during the day. So that will save on a lot of generator stuff. But yeah, moving forward, I think we're a bit stuck in this model in terms of using battery systems. Like I say, solar is lovely, but you've got to have a lot of real estate for it to be effective. And that's not always available in the nice sunny locations that you need it. Wind has been used. I think Glastonbury got a wind turbine that they actually had to power up one year to make it turn around so it looked good on camera. But again, it's a contribution. It's not going to make massive inroads into the effectiveness of it. But I think the biggest challenging facing the industry is sustainability and being able to deploy green technologies in temporary power systems, whether that's construction events or similar.
Interesting. That dovetails very well into another question.
Hold that thought.
What strategies do festivals and events use to offset their carbon emissions, particularly generation from diesel, the diesel generators and so on? What is that a thing?
That's a question I'll have to think about. I think generally, when you look at what you have to look at is something like that holistically as well. So you think about the festival, it's the transport of getting people to the festival, because they all drive down in their cars. Some festivals now ban car parking and make people come on public transport and provide additional public transport for that. Generally, in the overall scheme of a big event like that, the actual power generation is a smallish part of the bigger picture. It certainly was at the Games. It wasn't when you're flying athletes from all over the world and using all these venues, the power is a relatively minor part of the carbon emissions. We played our part in that whole process. But for that, it was just planting a lot of trees to offset it, really, was the way around that, as is common in many other industries at the moment. So, but yes, in terms of what the festival roadmap is, there is an organisation that's looking into that. I can't remember where they've got to on it, so I'll have to come back to that question with a bit more of a considered answer later on.
This may be a daft question, but we've seen all the power and the 3-phase and the 5-wire. Where's your reference Earth? What do you do for Earth at these big events?
Well, I know a very good book on that subject, about to be available for pre-order from the IET. Shameless plug here, but right. we don't use Earth as a reference, and that's the biggest misnomer in electrical safety. Earth is used as a method of fault detection, and that enables protection, usually in the form of automatic disconnection, to work. So if I've got a generator sitting here powering this monitor, if there's a fault with the monitor and the casing goes live, or current, live wire falls out, touches that, current will flow down the green and yellow wire straight back to the generator. The mass of Earth has got absolutely nothing to do with that process. So we don't need Earth in that respect. Now, there are certain fault modes that can happen, like insulation damage on a cable lying on the floor. So we'll connect the system to Earth to provide that fault return path to allow the Earth leakage relays to operate. So Earth is, the connection with the mass of Earth is a fault path. And so that's what we use it for. Well, that's what any generator will use it for. So there are some sort of fictitious numbers like 20 ohms as a value for an Earth electrode for a generator, which has no foundation in anything. It's really, you need to get enough current flowing to operate the protective device. So in terms of how you do it, you'll see broadcasters putting spikes onto the wheels of trucks and things like that, which is next to useless. Often it's actually better to use metalwork that's already available. So I've connected to fences, street posts, and things like that before now, because I've got a nice big lump of metal buried in the ground. It's going to be far better than a rusty rod, a couple of feet in a ground I don't know. So, but again, it's measuring it is a bit of a challenge, because when you've got a concrete street and you want to be able to put your test spike down, you can't. So there's an element of, to be blunt, a lot of, hopefully it'll be all right. So.
The mix system where you had the battery systems turning the generators off because of the kind of load they are. Is that just a design thing? Is that fundamentally solvable?
Sorry, where we transferred the load from the battery storage unit onto the generator.
That's right. Yeah. And it,
so effectively, if you imagine you've got a bus, you've got the battery, you've got the generators, you've got the load. So once we said, right, okay, let's bring the generators on stream, take the batteries offline so that we can charge them up, and you dump that load straight on the generator, that's when the generators fell over, because they weren't expecting such a leading power factor, because of course the batteries have been masking that. So two ways you can do it. One is you can just use a generator, depending on the battery structure, to charge the batteries, but generate enough to power the load and do the battery at the same time. That can work. But yeah, the other way is just to dump a big load bank on it.
Right, thanks.
Is the current cure. Because inductive load banks you can use, but they're very expensive, and they're like hen's teeth in the UK. They do exist, but yeah, it's a challenge to set them up.
So taking that argument a bit further, one suggestion from Paul Muller is, with all the problem with switch mode power supplies, would DC distribution be better, assuming that you could get all the devices to run on DC?
Yeah, and there's a lot of talk about this, because pretty much everything now is powered by DC. All lighting ends up as DC. Even things like washing machines, DC as well, I think, for the most part. And it's all powered using a switch mode power supply off AC. So, but it would take, I don't know how you go about persuading all the manufacturers really to switch over their products to run off DC. And the DC distribution, the protection and everything would require a completely new distribution kit, which will work with DC as opposed to just AC. It'll be a big challenge. But I think that's a challenge that faces the UK anyway, in terms of providing that, going down that DC route, which wouldn't necessarily be a bad thing, but yeah, it would be quite hard work, I think.
James, I think we've come to the end of it, but that, and I'm sure everybody in the audience would agree with me, was a fascinating view into a field we didn't know anything about much until tonight.
But you've all seen events.
We have. That's the point. You see it from one dimension. What we've seen tonight are a lot more dimensions. And I would, on behalf of the audience, thank you very much for coming and giving us such a fascinating presentation. Ladies and gentlemen, would you join with me in thanking James?